Hello, everyone. My name is Patrick Kane, Regional Sales Manager with Big Switch Networks. I'm joined by Dwayne Wenger, Senior Systems Engineer, also with Big Switch. Today, Dwayne and I are going to talk to you about cloud-first networking. We'll take a quick look at the agenda. What is cloud-first networking? Why are we presenting cloud-first networking to you today? I'll do that part. I'm going to hand it over to Dwayne, who's going to give you a product overview. He'll give you a demonstration on our products. And then we'll talk to you about next steps regarding cloud-first networking. So almost everyone has heard the term cloud, but really, what is the cloud? Well, we'll start by what the cloud is not. Cloud isn't a location. It's a set of design principles. Just building the same old data center isn't enough anymore. Look at Amazon as an example. When building its data center for Amazon.com, they realized they needed to design and build a modern data center that gives application teams the experience they actually want and require. But in order to accomplish this, they started with a clean slate and they built a cloud networking solution so agile that it could adapt on demand to meet their internal application teams' needs. By building a networking solution with developers in mind, they built AWS, an infrastructure that we know today as cloud networking. Amazon designed what has become the de facto experience for application developers worldwide. They created what we know today as the Virtual Private Cloud, or VPC. Now, the VPC has been one of the single most important innovation in network infrastructure since the VLAN or VRF. But it's the lack of innovation up until now that has created what we might think of today as network dread for application teams. For developers today, navigating their network can feel as frustrating as sitting in bumper-to-bumper rush hour traffic. Sure, they might successfully make it from point A to point B, but they're bound to experience slowness along the way as they develop and manage their applications. This is a good way to think about your network today, comparing it to public roadways. Your network is a massive infrastructure project, but made up of legacy systems. Keeping it maintained over decades is no small feat, and the task of managing and maintaining these legacy networks has become increasingly difficult day to day. Demand is expanding and network teams are shrinking, and the responsibility of the network admin isn't just to build more roads. They also need to be the head of highway patrol, road repair crew, and overall city planner, all in one. Network teams today are burdened by operations that are slow and complex. They're still bogged down with manually configuring VLANs and scripts, asking the teams around them to wait for maintenance windows. Think about an AWS architect asking you to wait several weeks for a maintenance window. It's simply unacceptable. Also, networks have limited visibility. In today's world that's basically all virtual, you really have to know what VMs and containers are connected, where they are connected, and what they're doing in real time. As well, networks lack operational consistency. Wouldn't it be great if you could have the same management experience, the same deployment experience, no matter which cloud you deploy in? Because remember, hybrid cloud means that on-prem is part of the cloud too. Together, these three challenges mean the network teams cannot properly serve their applications team or the overall enterprise. The traditional network vendors have been trying to sell you on the idea of building a new overpass or extending lanes in the same antiquated designs they've been pitching for decades. It means that your application teams are constantly waiting in bumper-to-bumper traffic, knowing that they can get the flying car experience in order to get out of the traffic, such as a VPC from the cloud providers like AWS and Azure. And often, that's exactly what they do. App teams have resorted to treating us, the network teams, as someone to work around rather than someone to collaborate and work with. And that notion is more dangerous today than ever. The more apps there are to connect, the more critical the role of the network becomes. Ultimately, this is because the network hasn't evolved, and it absolutely has to. In order to make the roads less complicated, rush hour much less painful, and just a better overall experience. We have to think differently. We need to take a radically different approach. We need innovation that's monumental and not incremental, and think and act like public cloud teams. It's time to bring the VPC experience on-prem. That's exactly what we do at Big Switch Networks with cloud-first networking. Our solutions bring the speed, agility, reliability, and experience you've gotten from the public cloud and bring that same operational experience on-prem. By building your on-prem network with the same techniques mastered by public cloud operators, we enable your enterprise teams to design, build, and operate a data center for the future today. If you want the same cloud experience enabled by VPCs, the same agility, the reliability, and security, we have to apply the same design approach. We can leverage the principles mastered by public cloud operators to build a cloud solution on-prem. This cloud-first approach to infrastructure uncomplicates networking. No roadblocks, no detours, no potholes, no more network dread. When you operate like a cloud, you can offer like a cloud, providing your application teams with the same network as a service experience regardless of location. Your network team delivers the consistent management and experience across all of your enterprise cloud deployments, no matter where they're located. So let's see how this affects the different teams within your company. Your executives get what they ultimately want: better productivity per employee, without the heavy burden cost of deploying applications to the public cloud first, and preventing unbalanced cloud affinities. Your app team gets the as-the-service experience they've always wanted on-prem. Your operations team now have the visibility into everything. They can deliver quickly and consistently to internal customers without compromising on reliability or security. Your network team can stop worrying about just building more roads. Your application team can get the flying car experience they want, and they get it on-prem from Big Switch Networks. We think one of our customers said it best. I chose Big Switch because it was the closest thing we could get to Amazon VPC networking on-prem. It's that simple. Only our customers can say that because Big Switch was born in the same Stanford lab that developed the technology that today enables Google Public Cloud, AWS, and Azure to offer services the way they do. With Big Switch, your app teams don't have to go to AWS to get the cloud experience they require. You could bring that experience on-prem. When they're using cloud features like VPC, they can go anywhere without the constant dread of being stuck or slowed down. And that freedom changes everything. So why not join your peers? Make your on-premise operate like the real cloud too. Now remember when we started, cloud isn't a location. It's a series of design principles that allow your enterprise to build a data center for the future, but you can build it today. So now I'm going to hand it over to Dwayne, give you a product overview of Big Cloud Fabric.
Thanks, Patrick. We're going to take a look at Big Cloud Fabric for the enterprise cloud, this being our on-prem data center networking offering. I do want to mention we have two focus areas. One is next generation data center and switching, the other being next generation data center security and monitoring. Big Cloud Fabric is what we're going to be focusing on today, and that is our data center switching offering. Big Monitoring Fabric is our corollary product for monitoring data center networks, as well as monitoring public cloud instances. Both of these solutions are architected on hyperscale inspired network architectures. That being, they're based around a controller. They're based on open networking hardware, which we're going to talk a little more about. And they also enable you to build scale-out fabric architectures. The easiest way to understand our architecture is to consider a traditional chassis pair. With traditional chassis switches, you've got supervisor modules, you've got line cards, and you have fabric backplane modules. Essentially what we do is we rip these components out of the sheet metal, wherein the role of supervisors is performed by our controllers. The role of backplanes is performed by spine switches. The role of line cards is performed by leaf switches. This entire fabric looks, feels, and acts like a single logical switch, hence the name of our company, Big Switch Networks. So how does this actually work? Whether this is Big Monitoring Fabric or Big Cloud Fabric controllers, the switches ship from factory without any operating system on them. These are known as white box or bright box switches from our hardware partners such as Dell EMC or EdgeCore Networks by Acton. The only thing that's on these switches when they ship from factory is something called ONIE, O-N-I-E, which is a bootloader. If you're not familiar with ONIE, you may be familiar with Pixie for servers. Very similar concept. The way this works, you provision the switch in the controller with its MAC address, plug the switch in, power it on. It downloads its software from a controller, and that software is from Big Switch Networks. It's known as Switchlight OS. The software is downloaded to the switch then reboots into Switchlight OS, and then starts up and becomes a component of the fabric. So let's look at a little more detail on what this fabric actually looks like. At the core of the fabric are the controllers. These controllers are always deployed in HA pairs for high availability. At the core of the controller is a REST API. We have three ways of interfacing and managing the controllers: command line interface, web interface, and also REST API. In fact, the command line interface and the web interface are actually REST API clients, meaning anything that can be done on these controllers can be done via REST API. We take advantage of that REST API and ship out-of-the-box integrations for platforms like OpenStack, VMware vCenter, and various container orchestration platforms such as Kubernetes, OpenShift, etc. The fabric itself is comprised of spine and leaf switches. It is a unified layer 2, layer 3 cloth fabric, all being managed from the controllers. We have implemented a hierarchical control plane, meaning that we have agents in Switchlight OS that handle a lot of the chatty edge protocols such as LACP, LLDP, etc., and allow us to scale these fabrics out. Switchlight OS is running all the physical switches. We also offer Switchlight VX for certain implementations of container platforms and OpenStack integrations where the fabric is not comprised only of physical switches, but also the Switchlight VX virtual switches deployed on Linux hypervisors. The important thing to keep in mind is this fabric is a single unified fabric. We are not doing something like an overlay-underlay arrangement where we would have ISIS or BGP running between the switches and then doing a VXLAN overlay. That is not what we're doing here. This is a single unified multi-tenant fabric, all managed from the controllers. Use cases for Big Cloud Fabric Enterprise Cloud on-prem. One is the P fabric, which means meaning that the fabric is comprised of the controllers and physical switches, many times used with integrations such as VMware, Nutanix, things like that. Another is using it as a fabric for OpenStack NFV deployments, where now we're integrating at a P plus V level and introducing that Switchlight VX vSwitch for your OpenStack deployments. A third being container environments. One of the things about containers, when you start to deploy these on-prem at scale, the networking options can get rather complex. When you deploy with the Big Cloud Fabric integration, we take the complexity out of that container networking. And then also using it just as a simple data center fabric for various workloads such as Hadoop, Hyper-V, Zen, etc. Some of the reasons customers choose Big Cloud Fabric Enterprise Cloud. One being simplicity. We abstract physical from logical networking. We're no longer configuring things on a port-by-port basis. You're now configuring at a higher level on an enterprise VPC basis, bringing that cloud VPC experience on-prem. Zero-touch fabric. Again, leveraging REST APIs, we're able to do things like install the Switchlight software automatically, configure link aggregation automatically. The fabric formation itself is automatic. I'm not having to define on my leaf switches which interfaces connect upstream to spine switches. That's auto-discovered. Upgrades. I can upgrade controller pair with the corresponding switches. Here's an example of 64 racks, 134 physical switches. Being able to do that in roughly 15 minutes and do that in a hitless fashion. And when I say hitless, what I'm talking about there is we're not impacting application performance during upgrade time. I'm able to continue running my applications at full scale while I upgrade the fabric without taking an application outage. Another reason is design. Being able to troubleshoot network traffic through the fabric, whether it's 6 switches or 64 switches, simply by choosing a source and destination and having the fabric trace out how that traffic is actually going to flow rather than having to go through on a box-by-box basis and see where that traffic is. Fabric analytics. This is built into the controller. This is a time series search log of all events and statistics that happen on the fabric. And we also extend this to our integration with their software partners such as VMware and Nutanix. And then fabric programmability. So I mentioned the REST API that's at the core of the controller. We do provide an SDK for that API, but we also have a feature built into the controller where you can simply issue from the command line a debug REST command. We can also do this via the web interface, where now each and every command that you issue, the controller will echo back to you what REST API calls were made in the background to allow you to start scripting, automating, things like that without having to dig through complex documentation. Another reason, resiliency at scale. I don't know if you're familiar with Chaos Monkey or not, but this was a technique that was developed by Netflix and contributed into the open source community. And the whole idea behind Chaos Monkey is, how do we introduce random failures into an environment to ensure that this environment is actually application resilient and not being, we won't be open to any critical failure causing application loss. We've leveraged that technique and built our own set of Chaos Monkey tools that we utilize in our QA. And we will not release a release of Big Cloud Fabric Enterprise Cloud unless we introduce these failures to that software release and we observe that we're able to take 640 component failures in 30 minutes with no impact on application performance. Many customers will ask, well, how do you actually deploy this inside to an existing data center where I may have existing workloads and existing networks already? The way that we do this is we adopt a core pod architecture, meaning the core data center routers are used to interconnect various legacy networks as well as big cloud fabric instances. We connect via layer 3 to data center core routers using BGP, OSPF, and even static routes. We can also connect at layer 2 for workload migration. In addition to that, we have the opportunity to extend layer 2 between big cloud fabric pods using VXLAN extensions. And we can also extend that to remote data centers in cases where that makes sense. One resource I do want to mention before I jump into the demonstration is Big Switch Labs. Here at Big Switch, we have an environment up and running 24/7, 365 at labs.bigswitch.com. I would encourage you to go and register for an account. It's free to use. On labs.bigswitch.com, you can actually experience what I'm going to show you today, plus much more. We've got modules on introduction to Big Cloud Fabric, OpenStack integration, VMware integration, automation, things like that. And then also Big Monitoring Fabric is covered on labs.bigswitch as well. What we're looking at right here is the initial dashboard for Big Cloud Fabric Enterprise Cloud, where I've just logged in. Upon login, this kind of gives you what I like to refer to as health and wealth of the fabric. Statistics about the controller, statistics about switches, whether it's memory utilization, CPU utilization, and then also at a glance, top talkers. We break this down by segment, enterprise virtual private cloud tenants, and then also interfaces right here on the front dashboard. Before I go through the rest of the web interface demonstration, I did want to show you what the command line interface looks like as well. I'm going to go ahead and connect as the admin user to this controller. And I've configured SSH pre-shared keys so I don't have to use password authentication to log in. What I wanted to show here is this command line interface is very much a network command line interface that you would expect to see from any standard network device. I can issue commands like show, and I can use the question mark to show context-sensitive help. We also support tab completion, so I can just type first few characters and tab out the rest. If I do a show switch here, I'm seeing all the switches in the fabric. Really, when I'm logged into the controller here, it's like I'm logged into a supervisor module of a really big chassis switch. For the rest of the demonstration, we're going to continue on in the web interface. So I mentioned earlier that we abstract the physical from the logical networking in Big Cloud Fabric. Anything under this fabric drop-down over here deals with physical networking. Anything under Enterprise Cloud, that deals with logical networking. We're going to start out on Fabric. If I click on the word Fabric, this is going to give me a visual topology of what my fabric looks like. I mentioned in production you would always have 2 controllers. In my demo lab environment here, I only have a single controller. So this would not be considered a production-ready, high availability deployment. Here I can see the spine switches that I've got deployed, as well as the leaf switches. In Big Cloud Fabric, we organize our leaf switches into what we refer to as leaf groups. Each leaf group contains 2 leaf switches. If I click on Show Links over here, this is going to show me how things are actually physically connected. This is not based on configured state, this is based on discovered state. Here I can see that in my leaf group, I've got the switches connected together by what we call interleaf connections. And then we've got from each leaf switch a connection to each and every spine switch. There are no connections between spine switches themselves. I'm going to continue down here and go to the switches section. Here I see all the switches that are currently in the fabric, their current state. If I want to see more information about these switches, I can always click on this Show Hide Columns and see all of the additional information that I could load into this table if I wanted to. I mentioned the process of adding a switch being a simple click. Let's go ahead and take a look at what it looks like to add a new switch to the fabric. I would simply click plus here for provision switch. Name that switch. Let's say I was adding a 3rd spine switch. When I typed the word spine, the web interface saw that that matched a role of being a spine switch. If I type the word leaf, it automatically sees that it's a leaf switch. If I type something that's not matched, I can always choose and override what role that switch will have. I would simply populate the MAC address of the switch in here. This is not actually a valid MAC address, so I'm not actually going to go through adding it. But essentially here, when I hit save, this would then have the controller ready for that switch to come online. Continuing down to interfaces, this gives me a fabric-wide view of all of the interfaces in the fabric. So like I said, it's like logging into a supervisor module of a really big chassis switch. One thing I do want to highlight here is I can search up here in this filter table row for any of the values that's displayed on the screen. So let's say I wanted to find any interfaces with ETH5 in the interface name. I could just simply type there. It's going to sort that out and show it for me. I'm going to go ahead and remove that filter. This searchability applies to any of the table views within our controllers. Moving down, I'm going to also highlight interface groups. These are the equivalent of our link aggregation or ether channel groups. I have defined here BM0 through BM5. These are attachments to physical servers that I've manually created. Notice here under discovery, there is no discovery protocol listed. These interface groups down here that start with ESXi, these are a little bit different. These interface groups were dynamically created using our integration with VMware vCenter. So I've got a vCenter instance here that I've integrated with, and essentially what I'm doing, what the controller does rather, it pre-creates an interface group for each vSwitch on each hypervisor, and then it watches for LLDP or CDP packets coming from the hypervisor and automatically puts the interfaces into the proper interface group, thus eliminating one of the steps that has to be done when you're bringing new servers into your data center environment, not having to manually create those groups on the top of rack switches, letting the automation capabilities of the platform take care of that for you. Coming down to Fabric, going down to connected devices, this shows me all of the neighbors that I've discovered connected to the Fabric, whether I've discovered those via CDP or LLDP. We do have the ability to configure storm control profiles. If you wanted to limit the amount of broadcast traffic, multicast traffic, etc. on the Fabric, I don't have any configured here. But all of that is having to do with the physical state of the Fabric. Over here under Enterprise Cloud, this is where we configure logical networking. I'm going to go ahead and click on Enterprise Cloud. And here are our Enterprise VPCs. our enterprise virtual private clouds. You can see here I've got one named Lab, I've got one named vSphere, I've got one named External, and in the center I've got a VPC named System. This system router is, the system VPC is really like an inter-tenant or inter-VPC router. This exists on the system at Fabric Bringup. In fact, that's the only VPC that exists. These other ones that I have here, External, Lab, and vSphere, I created, or they were automatically created via integration with an external platform. This system VPC is what we use to route between the other enterprise VPCs. Let's go ahead and take a look at the Lab VPC. I'm going to look at the graphical view of the Lab VPC. And here I can see I've got 3 segments or subnets within this virtual private cloud. I've got a 192.168.253 subnet for my apps. I've got 252 for my database instances, and I've got a 254 for web instances. This is a classic 3-tier example. This can be built out however necessary for your environment. One thing I want to show, let's go back to Enterprise Cloud. Go down to eVPC tenants. I want to show the ease of creating a new Enterprise VPC. Let's say you've got a new application that's going to be built, or a new completely separate set of applications, and you want to create a new Enterprise VPC tenant for that application set. It's simply a matter of hitting the plus sign there, giving it a name. I'm just going to call this new app set. Choose whether or not this tenant should be multicast enabled or not. For this case, I'm going to say I don't need multicast and just hit save. Coming up to Enterprise Cloud, that new app set is now created and ready to go. I can start provisioning that or even give another team access to it to start configuring it. It's not connected to the system tenant router yet, so I don't have to worry about it interfering with the rest of my network traffic. Once that whole VPC has been configured, I can then go through compliance checks with the corresponding teams to make sure that everything is ready to go. And then at that point, I can simply manage the system tenant interface and connect it into the system router to start routing traffic between all the VPCs. Let's go ahead and drill into the vSphere Enterprise VPC and take a look at this one and show some of the power of the automation that we've built with external platforms, in this case being vCenter. Here, if I take a look at the vSphere tenant, I can see multiple segments within there that have been pre-created via our integration. I can see vSphere 0 through various segments. If I go over here into vCenter and take a look at the networks, all of the segments or subnets on the physical fabric correspond to a port group within vCenter. I'm just going to go ahead and create a new port group and observe the automation that we've built in. I'm going to go ahead and create a new port group in vCenter, and let's just say this is for security workloads. I'm just going to call it security. I'm going to assign it a VLAN ID. In this case, I'm just going to choose 26. I'm going to configure my teaming and failover policy to be route based on IP hash. I'm going to go ahead and finish here. Come back to Big Cloud Fabric Enterprise Cloud and refresh my view. And I can see that vSphere 26 was automatically created. If I hover over here, I can see the description being one vSphere port group security, which is what I named it over in vCenter. That was automatically created for me. At this point, any workloads assigned to that port group within vCenter will be able to communicate with each other. They will not be able to communicate to the other segments in here until, as a network administrator, I come in and create the default gateway for that subnet. And apply it. At that point then, this subnet is ready to talk to all of the other subnets. If I wanted to, I could define policy list to limit what traffic is allowed between subnets, what traffic is allowed between tenants, what traffic is allowed in and out between the external tenant for the outside world. Moving over, I'm going to take a quick look at the integration with vCenter from a network operator's point of view. If we think about the typical network operator's experience when you've got something like a VMware vCenter environment running on top of your network, from a network operator's point of view, you're kind of flying blind. You don't really see what workloads are attached. Via our integration, not only are we automating network tasks based on the desired state of the attached workloads, we're also providing a tremendous amount of visibility into the network, into the workloads that are attached. So right here from Big Cloud Fabric, I'm able to see my various VMware hosts that are attached, which vSwitches are there, how they're physically connected, getting down to exactly which Ethernet interface off of the server is plugged into which Ethernet interface on my leaf switches, what port groups are attached, and which VMs are attached on those port groups. I can see all of the hosts that are attached, what vSwitches are there, the physical connections, and all of the endpoints, whether those are virtual machines or VMKs. In addition to vCenter integration, we also offer integrations with Dell PowerEdge MX chassis, Nutanix Prism, VMware NSXV, and we're working on NSXT integration for an upcoming release. Of course, we also offer the things that you would expect from a network environment. Things like quality of service, simple things like clock synchronization, SNMP monitoring, AAA, being able to authenticate users and administrators via Radius or TACACS servers, SFlow generation, logging, we can send syslog information to remote syslog servers. We can support VXLAN termination, again, for interpod use cases, or we can act as a VMware NSX hardware VTEP if necessary. From a visibility standpoint, I mentioned the test path feature. Let's go ahead and take a look at how that actually works. I'm going to go ahead and grab two hosts that are attached to the fabric. We're going to take a look here. Is this host named BM0 has an IP address of 192.168.254.10. This one over here has an IP address of 192.168.252.14. I'm going to join and just start a ping session between these two just to generate some network traffic. And I'm actually going to say I want to see exactly what's happening with that traffic. I'm going to search for the originating host in here. Search for the destination host. The protocol I'm going to be looking for is ICMP because I've got a ping session going on. If there was other sort of traffic on the network that I wanted to look for, whether it's VXLAN, iSCSI, or something custom, this is where I would define that. I'm going to go ahead and do that test path right here. Just going to give it a test name. Hit submit. What this is actually going to do, it's going to go out and query the TCAMs of all of the switches and find out where those packets are actually hitting and how they're traversing the fabric. And then it's going to actually display me a visual on how this traffic actually is passing through the fabric. You can see this is counting down over here, down to 10 seconds, and will soon be displayed. Here I'm seeing the traffic come in to the leaf switch on Ethernet 8 interface, egressing then on Ethernet 7, coming into the spine on Ethernet 4, and as I'm hovering here on the right, you'll notice the panes on the left are following me along, showing me exactly where it's coming in and going out, with various other statistics. From the spine, down to the leaf switch, and then from the leaf switch out to the corresponding host. Under Edge, you can see various things like the total endpoints on the fabric. You can see all the routes that have been learned or statically defined. You can perform route lookups. I can see any multicast groups that are out there. I can see I've got 2 layer 2 listeners I can see I've got 2 layer 3 group segments as well. And of course, under security is where I can configure multiple users, groups. These would be local users and groups, but they can be backed by a TACACS or a Radius server. Thanks for joining the Big Cloud Fabric overview, and I'll turn it back over to Patrick.
Thank you, Dwayne. Great job. So I started the presentation talking about cloud-first networking. Dwayne then walked you through a product overview and then showed you the speed, flexibility, and operational experience of Big Cloud Fabric. Now remember, Dwayne had a slide. You can use this product today. Again, BSN Labs, labs.bigswitch.com. All right, 24/7, 365. For more information on cloud-first networking by Big Switch, feel free to reach out to me, patrick.kane@bigswitch.com. We thank you for your time today and look forward to speaking with you again. Have a great day.